classic diet-heart hypothesis is described as an increase in saturated fat, increase in cholesterol, and a decrease in polyunsaturated fat in the diet leads to an increase in serum cholesterol, which then leads to erythematosus plaque, leading to coronary artery narrowing, then a myocardial infarction. This hypothesis can be supported by many studies, which we will discuss. There are three descriptive types of study. First, there was the ecologic study that took the mean intake of dietary factors of 16 populations in 7 countries to see the incident rate of CHD. It resulted in a strong correlation between saturated fat as a percent of calories to CHD rates. A migrant study by Kato et al. In 1973 compared the CHD rates among 3 Japanese populations in 3 different cities. The ones living in San Francisco had the highest saturated fat as percent of calorie intake and had higher CHD rates, proving an increase in CHD rates were not based on a genetic factor. Finally, secular trends are of interest but tend not to support the classic diet-heart hypothesis. The correlation between diet and blood cholesterol consists of 2 parts, relating diet to blood cholesterol and then relating blood cholesterol to CHD. Many studies show that an increase in dietary cholesterol leads to an increase in blood cholesterol. When relating blood cholesterol to CHD, we have to think about how the cholesterol breakdown. You can see from the graph, lower HDL plus high total cholesterol leads to a higher risk of CHD. Case control studies leave too much room for recall bias, therefore results always have uncertainty. Cohort studies lend themselves to this type of research because they are free from recall bias and should result in more consistent findings. The only consistent finding of early cohort studies was that increased energy intake was inversely correlated with risk of heart disease. This should be understood that a higher level of physical activity was inversely related to the development of heart disease. Limitations of early cohort studies include many studies were conducted with under 100 participants, many used 24-hour recall to represent food intake for 12 years of follow-up, long follow-up periods may reflect diet consumed closer to the end date rather than the overall diet, did not adjust for known factors, did not adjust dietary factors for other dietary factors. For example, fiber intake is inversely related to saturated fat intake. Studies showed that fiber intake is also inversely related to the risk of CHD. This is more a factor of the role that fiber plays in saturated fat intake. The Nurses' Health Study addressed all of these issues by having repeated assessments and adjusting to look only at the impact of fat instead of overall caloric intake. This study found a strong correlation between trans fat intake and CHD. Costa Rica case control evaluated the relationship between palm oil and the risk of CHD. Subcutaneous adipose was analyzed, and an FFQ was used to assess diet. Findings of positive association with adipose concentration and trans fat intake. Cohort studies require a population with diverse diets. It's possible that saturated fat and cholesterol intake did not play a role in CHD due to participants' diet being too similar. If saturated fat's role is mediated by its effect on cholesterol, then the relative risk is small enough to only be detected in a large cohort study. New research on diet and heart disease shows a relationship between added sugar intake and the risk of CHD. This was conducted as a cohort study and found that participants who consumed greater than 10% of calories from added sugar had a higher risk of CHD. The Sugar Research Foundation downplayed sugar's role in CHD in previous studies. Fatty acid intake is measured using plasma lipids, platelets, or subcutaneous fat. The use of biochemical analysis provides information about dietary fat intake, such as type of fat consumed and level of processing. The use of platelet and plasma markers in case control studies can be questionable because they can easily be affected by either dietary intake or behavioral patterns. Adipose tissue, on the other hand, has an advantage in this type of design because the half-life of fatty acid levels in adipose tissue is much longer than that of plasma. Limitations of using tissue fatty acid is that the proportion of a specific fatty acid could be affected by another fatty acid. Also involves fatty acid levels in tissues can be affected by whether the fatty acids are produced by the body or not and metabolism. Due to this, there is a weak correlation of endogenous fatty acid to intake. The LA and Finnish trials, U.S. men were followed for 8 years and results revealed that the men in both groups had heart attacks, but results were not significant. The Finnish men in both hospitals had reduced CHD diagnosis, and both groups had a 51% reduction rate in CHD deaths. After a 1-year and 5-year follow-up period in the Oslo study, those in the intervention group had decreased their cholesterol levels by 17% and 13% respectively. Heart attacks also decreased by 47% in the intervention group. Results in the Women's Health Initiative trial after an 8.1-year follow-up shows those following the intervention diet had no change in CHD risk. Total cholesterol does not fully represent the effects of fat on the risk of CHD. LDL and HDL play very different roles in the development of heart disease, but both are serum cholesterols. The development of heart disease is not merely about the amount of LDL, but also how it interacts in the body. Factors such as smoking and antioxidants affect how LDL is modified. There are many factors that still need more research. Trans fats are produced through a process known as partial hydrogenation. Many studies conducted in case control perspective and nested case control designs have proved a positive association between trans fatty acid consumption and CHD by increasing LDL levels, increasing inflammatory factors, and decreasing HDL cholesterol. This was seen in the Nurses' Health Study in 1980 when women who consumed the highest amounts of trans fat also had high risk of heart attack. Due to the many studies done on trans fatty acid, partially hydrogenated fats were banned in Denmark, Brazil, and Chile. The U.S. has no national ban. However, some cities and states such as New York City and California have banned trans fats. U.S. may not have a national ban, but the research did lead to better food labeling. Nationally, trans fats are required to be listed on food labels. Studies help shape the dietary guidelines for many foods and nutrients. A connection between an increased consumption of fish and low rates of CHD were found in Japan and Greenland. This, along with other studies, led the U.S. Department of Agriculture to suggest at least 2 servings of fish per week. It is now suggested to consume whole grain versus refined grain in our diets as well. Also, according to a Nurses' Health Study cohort, a diet high in cereal fiber, polyunsaturated fats, marine omega-3 fatty acids, folate, and low in trans fat and saturated fat strongly predicted a decrease in CHD. It's clear with all the studies done that there is a relationship between our diet and the risk of coronary heart disease. We all have to be aware of the foods we eat and the recommended daily intake to keep us safe from CHD risks.